Hello and welcome to All Space Considered, everybody. I'm Dr. David Reitzel, and with me is Laura May O'Brien, Ginger Rose Brucker, and Jared Head. And well, thank you, everybody. All Space Considered, you can follow us on these social media, and the program is presented by the City of Los Angeles Department of Recreation and Parks. And as always, we thank Griffith Observatory Foundation, our exclusive nonprofit partner, for all the support we get. Tonight, we have a really great show for you. We're here on almost every third Thursday of the month, so come on, see the show in person or watch us on YouTube if you happen to be seeing it there. And tonight, we've got a space news section where we're going to talk about possible signs of life caught with Webb, perplexing perpendicular planet, Lucy contacts a binary, and Curiosity catches KG carbonates. See what that's all about and how KG can a carbonate be, I don't know. And then we're going to do the MOSTIS, VTF at the DKIST. I think the kids understand that.
That's right.
Well, and NASA folks will. Everybody that loves a telescope. Then we're going to do some amazing astronomical images with Ginger, and we'll do an out to launch with Jared. And then we've got a very special section to celebrate 90 years of public astronomy here at Griffith Observatory. That's right. Yesterday was our 90th birthday, and today marks the 90th anniversary of public operation. And to celebrate that, we have Observatory Deputy Director Mark Pine and Griffith Observatory Foundation Executive Director Elizabeth Greenway to talk about what we do here with the public. So yeah, one more round of applause for them, sure. So to kick things off, we're going to start off with the story about Webb, and it did make some analysis of a planet, an exoplanet. This exoplanet is 8 to 9 times the mass of the Earth, so it's a bit bigger. It's less massive than, say, Neptune, but it's pretty big. Now this exoplanet's known to, well, we think it probably has liquid water in it, but Webb somehow saw signs of life on this exoplanet. How did it do it? Well, let me tell you about it and whether they're real or not. So first of all, this exoplanet, like I said, it has a liquid water ocean, we believe, an atmosphere of hydrogen above it. It's sort of like a mini Neptune or a super Earth, about a little less than 3 times the radius of Earth. So it's bigger. It's not really Earth-like. And these chemicals that were found, it's dihydrogen sulfide and dihydrogen disulfide. It's not too important that you know exactly what they are, but what is important is the fact that these chemicals are only produced by life here on Earth. Everywhere else, they're actually produced, well, by life. Biologic life makes them here on Earth. We don't see them naturally produced anyway. They get broken down. So again, here's how it compares to Earth, and you wonder, could there be biology on this exoplanet? Could it be microbes that are making these little bursts? So now, here's where it orbits. The green zone is where water would be liquid on the surface of the planet if it's really there. We think there's water there. Now, the planet orbits just inside that zone, though, so it's a little warm. It's a little warmer than we'd expect. And by the way, team, the slides are forwarding themselves. Somehow every slide has a 30-second forward on it instead of just the ones at the end. So we're going to have to be on our toes. So apologies to the audience out there that's watching and wondering, what's with the back and forth? Anyway, this is what a spectrum from the Webb telescope looks like. The little dots are actually what was measured, and underneath is the synthetic spectrum that we think we saw. We've seen methane on this exoplanet, we've seen water vapor, we've seen carbon dioxide, and like I said, this chemical that's only made by biology here on Earth. Now, we can make it in a lab. Humans can make some equipment like this, but again, to make equipment like this takes biology. We're biological, so yes, but it does make you wonder, could the universe set something up like this? Could, say, an M-type star, it's a red dwarf, a flaring red dwarf, could it somehow create that chemical in there? Maybe it could. Well, we also see this dihydrogen sulfide in comets, like 67P there, and we also see it in Ryugu asteroids. So it's also seen in big clouds of galactic gas that's out there. So gas out in space also has this happening to it and has this chemical. On Earth it breaks down, but maybe it's naturally occurring on this planet. We're not sure. And also the data were only about a 3 sigma result. And what that means, it's something like 1 in 10,000. We normally like a 5 sigma result, which is whatever, 1 in a million, something like that, before we're really confident that it's a real result. So they're going to get more data with Webb, they're going to take longer exposures, and eventually they will know whether it's real or not. We'll get back to you. But this is the first indication that might be real of biology on an exoplanet. So exciting times.
To be investigated further.
Yeah, to be investigated further.
Another very exciting discovery that was made, that was made in the southern hemisphere. So you may be aware the Mauna Kea out in Hawaii, large volcano that we have many telescopes on. Well, down in the southern hemisphere, down in Chile, we have many observatories also down there. And so this is an image showing you the European Southern Observatory's very large telescope where this very exciting discovery was made. Let me see if there we go. Now, what you're seeing here are some eclipsing binaries brown dwarfs. Let me break this down. So brown dwarfs are types of, they're rather hybrid objects that are somewhat between stars and very, very massive gas giants. They're actually fusing deuterium, but they're not full-fledged stars, right? But they can be orbited by planets. And so the AB pair that you're seeing here, those are 2 little brown dwarfs that are orbiting each other. So you can't resolve them individually. And then further away, quite some ways away, we've got another brown dwarf that is also connected gravitationally, right? So this is where the discovery was made. Now, very excitingly, in going around this AB pair, we have a planet. So this is an artist illustration. We are not yet capable of having beautiful images like this, though we wish we could. And they were able to find a very unusual planet. Now, we call these exoplanets. Those are planets outside of our solar system. And we have found about 5,000 of them so far, just above, I think, close to 6,000 now, confirmed ones. And they can be in very exotic configurations, right? We can have systems that are very close to their star, very far away, with unusual, very, very elongated orbits. And this planet is very special, so it is called 2M1510ABB. We love it. It's very catchy, right? So this usually refers to catalogs, by the way, when you see numbers and things like that for names of planets. And so what you're seeing here, let me explain this little diagram to you. So you're seeing those 2 little eclipsing binaries, those little brown dwarfs. They're orbiting this common center of mass, right? And around it is that planet. So we call these circumbinary planets. And we've found fewer than 20 of them so far. We've found about 16, 17 of them. So they are already pretty exciting. They might be compared to Tatooine, for anyone who's seen Star Wars. Yeah. Some of those planets that have 2 stars, that is a real possibility out there. But this planet is exciting because it has a perpendicular or polar orbit, right? Now, when we think about the solar system, we think about our star in the middle, and everything is rotating in a nicely arranged flat disk around it. And that does tend to be often what we see, because if you want to get deep into the physics, we have what we call conservation of angular momentum. So often when these disks are forming, everything is spinning in one direction, and that tends to stick around, right? But this planet is going in a very unusual orbit, again, perpendicular to the way that these stars, or these brown dwarfs rather, are rotating. And furthermore, we see something called precession. So what you might have seen on this, let me show you this previous image again. So I don't know if we can see it very well on here. I forget if we have an animation, but what you're seeing, those stars are actually, the stars themselves are precessing. So they have a, how shall I describe
you can see the orbit here. The closest point to the star is changing, and the furthest point is moving around like a hand of a clock as the planet orbits. So as these 2 stars are orbiting one another, they're actually changing their direction in space as well. So they're sort of spinning around one another as they're orbiting. It's a complicated dance.
And almost everything, by the way, that rotates has precession. Our own Earth has precession, and it creates this kind of rosette pattern that you might be seeing in the right there in blue, these little blue circles. So this is again to show you the architecture of this system. So we have this much further away other brown dwarf, and that one does not have gravitational influence. So what's curious about this is, how did this planet actually end up in this type of orbit, right? These are pretty rare. We do find a couple of hot Jupiters. Those are massive, massive gas giants that we find very close to stars. We found a couple of them that are in these polar orbits. And in our own solar system, we have a couple of asteroids that also orbit in these rather very inclined orbits, but it's fewer than 1% of them. It's only about, I think, about 250 asteroids. So to show you, this is the animation showing you the dance that is happening. It's rather extraordinary. And this discovery was made by accident, by the way.
Now, keep in mind, the exoplanet is actually going perpendicular to the stars. You have to kind of make your brain see that, because I'm so used to seeing everything moving in a plane. Your brain wants to see them all in a plane, but it's not. It's actually going up and over the top now and then going down below. And the way they discovered this is actually by measuring that precession of the star's orbit. They don't see the exoplanet at all. It's through the spectroscopic analysis of these brown dwarfs that they're precessing. Something has to be making them precess. Yep. So what do they think it is?
So they're not sure yet if it formed in this way. Occasionally there have been ideas in the past about capture. You could potentially have a capture of a body, or you can also have, we have some mechanisms such as the Lidov-Kodzai mechanism. This is kind of deep physics, but it's essentially an exchange. You can have an exchange between bodies of your eccentricity, so that's how elongated your orbit is, and your inclination, so how inclined that orbit is to the plane. Yeah. So you can have all sorts of mechanisms, and you can have disruptions.
Now, what was that mechanism again?
The Lidov-Kodzai.
Oh, that one.
Yeah, that's right.
Don't worry if you don't know that.
Everyone's familiar with the Lidov-Kodzai mechanism, right?
Yeah.
So this is going to be. We do have. There are some other exoplanets that have been found with inclined orbits, and like I said, some other hot Jupiters. But this is really exciting because it really is the first one we have found that has that type of polar orbit with a circumbinary. So this is the Upsilon Andromeda A system. So another highly inclined planet that is in the system. And what's also interesting, so this is to show you one of the very inclined orbits of an asteroid in our solar system. So this is Pallas II, and it is inclined by 34.8 degrees and likely a remnant protoplanet. So could we have some clues maybe in how it formed? We don't know how it ended up in this orbit either. But these are all part of considerations that we talk about when we talk about the three-body problem. You may be familiar with.
No, wait. Go back to go back to it here.
That's right.
No, go back even one more, because I was seeing looks in the audience, particularly from our deputy director. Why are they showing this? What's going on here is it's very difficult to model the orbit of three objects. It is, like she was saying, the three-body problem. And way back when I was in graduate school, people were working on this, and the idea was you have three objects. How do you model that? Two's easy. You can sort of fix one in space, make its coordinate fixed, and then have the other one go around, and you can do all the math. With three of them, if you take one and move it first, well, then the other two will respond to that new position. You can move each one at a time. Well, the orbits you get change completely depending on which one you moved first. So if you move object 1, you get one series of orbits. If you move object 2, you'd get a different set. It's chaotic, which is what this is showing. However, there are some orbits that are not chaotic. There are ones that sort of have zero angular momentum for anybody that cares about that. But these are ones that are, look how beautiful they are. They're making these sort of beautiful rosettes. And these are all stable orbits for exoplanets or a system of three. Now, could these happen? Probably not. But the universe is a big place. So I like to think maybe. And they're just pretty. So I wanted to show them. But the three-body problem, where have people heard of this? That's what you were rushing off to.
That's right. Probably many people now are familiar with this through the Netflix show, which was obviously a novel prior to this. But they actually, I think, have a four-body problem in this. I feel like this is I think they have three stars
I think three stars on the planet. And anyway, I read it, and I was wondering if it was a bad translation, because it's originally written in Chinese, and I don't know Chinese culture, so I'm wondering if there was a lot in there that didn't resonate with me because I didn't know the culture. So I found it a very interesting read, but
a nice introduction to a physics problem from a Netflix show.
Absolutely.
So now moving on to a very exciting space mission that doesn't get, I think, as much press as some of the other ones.
We're sending bones into space?
That's right. So the name of the mission is Lucy, and it is named after a very famous person. I don't know, I guess skeleton.
Well, skeleton.
Once a person, a very long time ago. So these are Lucy is the fossilized skeleton of an early pre-human ancestor that was found in Ethiopia in 1974. And it was named Lucy by the team of paleoanthropologists who discovered it, by the way, named after the Beatles song, Lucy in the Sky with Diamonds, which was very big at the time. And the fossil is about 3.2 million years, and it really helped us rewrite the textbooks on human origin. So a very, very important skeleton. So this is the, you'll notice, in fact, that skeleton shows up just on the patch of the mission. And so it was launched in October 2021. And just like the Lucy fossil provided unique insights into human evolution, Lucy mission actually promises to expand our knowledge of planetary origin. Now, how is it doing this? Well, it's visiting some very ancient worlds. So it's going to reveal some important information about the building blocks and collisions that might have happened early on in our solar system.
How big is this? Oh, there it is.
There it is. We actually wanted to put our director, I think, in comparison, you know, since there's so many interesting comparisons nowadays with number of elephants and things like that with asteroids. Bananas. But sorry, bananas. Yeah. I heard Taylor Swift's once as well. So all sorts of comparisons. So this is the main Lucy spacecraft. So it's got 3 instruments. It's got essentially one called LRAF, which is 2 instruments in one. We've got a color camera and an infrared imaging spectrometer. So it's essentially going to determine the composition of materials on the surface of asteroids. And then we've got a long-range reconnaissance imager, which is the high spatial resolution panchromatic camera. And it's also going to have a far infrared thermal emission spectrometer. I know these are very complex instruments,
now,
but doing...
Well, panchromatic, that just means black and white, right?
That's right.
Yeah.
In fact,
just checking.
In fact, most of the images we take in space, by the way, are black and white. The Hubble Space Telescope, many people don't realize it shoots in black and white. So it's going to also use the antenna to communicate with Earth for an additional radio science experiment to determine the masses of the asteroid targets. What's very exciting is that it's actually going to go very far out, and then it's going to come back. So here's its projected target, or its projected trajectory. So it's got a 12-year mission, and it's going to explore a record-breaking number of asteroids. It's actually going to fly by 3 of them in the asteroid belt. That is the little belt that circles the sun between the orbits of Mars and Jupiter. And then we're going to go to 8 Trojans. Now, we had someone from our staff who wanted to insert jokes about USC, I believe. There's some more famous Trojans around here. I know them as Greeks, but listen. So Trojans are these asteroids that share Jupiter's orbit, right? So they include, and we've got 5 asteroid targets in there. And Lucy, as I mentioned, is going to fly by Earth 3 times to get a push from our gravity. So it is going to be the first spacecraft to return to Earth, which is pretty cool from that region in space.
What's interesting about these Trojans is it's actually a stable place for them to orbit. Between Jupiter and the Sun, sort of notice they're, I forget how many degrees ahead and behind. I should know this number.
They're at, I think, L2.
Well, it's L2, yeah, I forget the number of degrees forward and back in the orbit, but notice they clump in those same spots. That's a gravitationally stable place to hang out. The gravity of the Sun, the gravity of Jupiter, it all balances out to where they have the same.
It's nice resonance.
Yeah, it's a nice resonance for them there.
Incredible trajectory that they were able to pull this off to get so many flybys.
Right?
So, it's fantastic.
That is, I think, one of the most interesting aspects of this mission. Yeah. So this, by the way, is the very first flyby that happened. This is Dinkinesh. You might be thinking, Dinkinesh, where does this name come from? Well, it's the original name for Lucy in the original language of Amharic, the language of Ethiopia, which, by the way, means, I think it means you are marvelous. So very lovely name. And we already had a discovery just from this flyby, which is that the little moon, so you're seeing that little round section on the bottom, that is the moon of Dinkinesh, and you can't really see it on this image, but it was the first discovered contact binary moon. So we're going to talk a little bit more about what contact binaries are, but essentially this moon is in 2 parts, right? So you might be wondering what this is. We can put some...
Laura May's lost her mind.
That's right. And let me tell you, many Photoshops were removed in the making of this slide deck. So Donald, very important in this whole mission, Johansen as well. Who is Donald Johansen? Well, Donald Johanson is an asteroid, believe it or not. So this is to show you the comparative size, roughly, of Donald Johanson with Dinkinesh that we just saw. Steins is one that we had, I believe, a flyby of, perhaps with Rosetta mission, and then Bennu and Ryugu that we had some samples from. And Donald Johanson is named after the paleoanthropologist, Donald Johanson, who discovered Lucy in 1974. So we like all these kind of names and going back and referencing things in science. So this is the orbit of Donald Johanson. So you can see here the Lucy mission and the orbit of Donald Johanson. You can also see where Dinkinesh is and the comparison to where Jupiter and our little Trojans are. Now, Donald Johanson is pretty interesting because it's part of a long-lost family of asteroids. So about 150 million, I know, sad, right? Yeah. About 150 million years ago, there was a very large collision, and this massive asteroid called Ergon, weren't sure exactly the pronunciation, but it created this massive family of asteroids, the Origone family. And so Donald Johanson is one of the leftovers from this. And so we just approached it on April 20th. So the probe was traveling about 13.4 kilometers per second. And we have, this is one of the very first images that was released of this carbon-rich asteroid. It has a diameter of about 4 kilometers. Anyone know the mile? I think that's about 2 miles, something like that. And it rotates very, very slowly. That was what was so exciting about it. It rotates in about 250 hours. And it is an elongated contact binary. So that is an object that forms when two smaller bodies collide. And they go very slowly, these asteroids, right? So they have a gentle collision in this kind of merging because many of them are what we call rubble piles. So they're just little piles of rather loosely put together. They're like little potatoes, little soft potatoes.
Rubbly potatoes?
Rubbly potatoes. So, and here is our amazing flyby. Pretty incredible.
Yeah, but what are they hiding off to the left?
That's right. So the cameras actually had to turn off after this because, as you can tell, the asteroid is illuminated by the sun. And so if they keep the cameras on as it's filming it or as it's taking images, then the camera, we do not want to put it directly facing the sun, right? But you're not seeing the asteroid rotate, you're actually seeing the spacecraft that is zooming past it. So, very, very amazing images. These are the first. There's nothing else that's been released yet soon.
I like the one boulder that's on it about halfway down in the middle.
It's very complex geology, so a very exciting time. And believe it or not, these are not, just like Dinkinesh, these are not the primary science target of the Lucy mission. So these are flyby tests. So Dinkinesh was the first test, and then this is the dress rehearsal, if you will. And so this is going to help calibrate all of the instruments, the cameras, for the real show. Now, if you're wondering where you might have seen contact binaries before, we have a wonderful little example. You might recognize this little image. This is one of our favorite comets, I think, of everyone at the observatory. And it looks, we have it right here, in fact, it looks like a beautiful little rubber ducky. Very important comparison. So again, unclear how this formed. It could have been these two pieces that slowly merged together. This is the comet that, very importantly, 67P, we landed, believe it or not, a probe on it about a decade ago called Philae. The Rosetta mission by European Space Agency was able to land on it and took some pretty amazing images.
Yeah, that last movie, by the way, was from our online school program and was put together by our very own Ella Ritz, and just a terrific job on that.
And so contact binaries now, this is telling us that they might actually be pretty common. So far we know about, we think they comprise about 10-15% of the asteroid population, but it could be as high as 30%. So here is an image of 216 Cleopatra. This is the first contact binary that was ever found in 1880 by an Austrian astronomer, and it has 2 little moons. So asteroids can have moons. They can have moons that are contact binaries. It's all pretty exciting and new stuff. And so this is to show you our next target. So here we've got Donald Johanson, not the paleontologist, the little rock here, in comparison to some of our other targets. So in August 2027, it's going to reach Euripides. So that's the main science target. It is a Trojan 10 times larger than Donald Johanson. So here's the progress of the entire flight of Lucy. So that was, we had the Dinkinesh and Selam, that's the name of its moon. Then we had the Deep Space Maneuver. Then we had the Earth Gravity Assist, so it came back in December 24. And then we had, it just flew by, Donald Johanson. And next it will go to Euripides in August 2027. Then another satellite, and then another Lucas. I'm not sure how it's. There's so many
Lucas.
Original, exciting names amongst asteroids. Oris.
Yeah.
One of those. So here's our full schedule. So it's pretty exciting. We're going to have 5 encounters between 2027, 2033. So keep watching.
Yeah, amazing to have a spacecraft go that many places. Well, quick story from Curiosity, which is on Mars, which has also been looking at various chemical signatures, sort of the same thing that Lucy's going to do by mapping out elements. Curiosity is a rover. A lot of people think this rover's kind of small. It's not. The body of it is about the size of, a Mini Cooper, and the wheelbase is about as wide as a Hummer. So those wheels are about as wide apart as a big Hummer on the road, pretty much filling the entire lane. And yeah, it's a big robot. It's a nuclear-powered robot driving around on Mars. Now, why did we send it there? We went to Gale Crater, climbing up Mount Sharp, and it was looking at the history of Mars, wondering, could Mars ever have been habitable? Were the conditions right for there to have been life there? And can we track that history? Can we go back and say, what were the periods where it was wet? What were the periods it was warm? When could life have been around? Well, we do think that Mars once had big oceans. There's a lot of evidence for that, from neutron measurements up in the, from satellites that are orbiting, to we see craters appear that have white material blown out on them, which then disappears. We think it's water ice that have been knocked out of them. So we've kind of tracked this buried frozen water, and we think, and we see signs that there were also, the stage changed. There's also signs that there's been floods on Mars, large amounts of water flowing. So we've seen that. Where did the water go? And also, if there was that much water, and if the atmosphere was a thick carbon dioxide atmosphere, which it needed to be warm enough to have liquid water. Mars isn't huge, and it's further from the sun. So to be warm enough to melt the ice, you had to have a thick atmosphere. Well, it should have had a lot of carbonate minerals. That water should have interacted with that carbon dioxide, and it should have created things like, these minerals. Siderite is one of them, and we didn't see it. We didn't see it in orbit. We weren't seeing these carbonates that should have been there. So then the question was, maybe the atmosphere wasn't thick CO2. Well, if you don't have a thick CO2 atmosphere, you're not warm enough, and then you don't have the liquid water. So it's very confusing. Well, now finally Curiosity, and you can see its rover tracks going off into the distance there, drilled into a rock, and this rock is layered. Look at all those layers in this sediment that it drilled into. The very bottom of it, it came across this siderite. Now you might want to know what it looks like. Here's Harvard University. They have some crystallized siderite. It's an iron crystal, iron sulfur element mixed together with carbon dioxide as well, carbon. It also looks like this. It can look like a plain rock as well. It doesn't always look crystally. Well, so we're seeing the signs that this siderite was locked up about 4 billion years ago. The problem is we're still not seeing enough of it. Even if all the sort of sulfur deposits that this seems to have been has this mineral, it's still not enough to make enough CO2. So there's still a little bit of a mystery there, but at least we're seeing it. And maybe if we dig deeper, maybe there's more deposits, maybe the story holds together, but at least we're seeing hints of it, and that Mars is kind of making sense. A mystery on Mars has been at least a little bit solved. Well, now we have a brand new section that we're opening up. We see headlines like this all the time. Hottest planet, furthest star, biggest galaxy, biggest black hole.
Speediest.
Speediest.
That was a surprising one.
Yeah, this 716 spins. So we decided to go the mostest. It's just fun, the mostest. And this time, Laura May, what are we talking about that's the mostest?
It's exciting because it concerns the sun, so obviously delightful. So this is the Daniel K. Inouye telescope, which is back in Hawaii. Land of the telescopes. So this is
he was a congressional person.
That's right. I think he had also other. He was very interesting character, by the way, Daniel K. Inouye. But this observatory has been functioning on top of Haleakala on Maui since November 2021, and it is the most amazing solar telescope in the world. It can do incredible things. And it just got a lot cooler because we have a new instrument on it. So it is a wait for it, a spectropolarimeter. Okay, I'm
Oh
sure
my
you.
gosh.
Oh, I can't
Really?
believe it! I'm so excited. There's a spectropolarimeter finally up there, right? And that just had its first light. So you're wondering what this is. So it is called the VTF. I believe that stands for Visible Tuning Filter, I think. And it will actually make its full debut in 2026. Now, why are we looking at the sun? How big is the sun? So here's to show you, before we show you the mostest, here's to show you some scale, right? So we have the Earth here, that tiny little blue dot, and we have the sun with some beautiful sunspots on it. So these are magnetic regions. You can think about them as magnetic storms. And we want to be able to get really detailed measurements and images of its surface. And the reason for that is that it's a very, very active place, right? So we do have to do a close study of it. It's the closest star to us, so one of the most interesting, right? And this is images and videos from the Solar Dynamics Observatory. So we are currently right on the tail end of what we call the solar maximum. So the solar cycle has a peak, and we get a lot of activity from the sun, a lot of solar flares. You might have seen that in the news. Most of the time, these are fairly harmless, but they can affect our technology.
Yeah, we're seeing some flares in this video. Every time you get a bright flash of the light, I'm going to reset it here.
Yep.
I'll point one out here for you. Right there at
Right
the start, there was one. And watch those lines. And by the way, you're seeing the gas follow the magnetic field lines. That flash right there was another flare that happened. And we think there, in fact, we know there's a connection between these magnetic fields and these flares, but we don't fully understand it. And flares can affect things here on Earth. They go off.
Yep. Radio
causes all sorts of
blackouts, GPS issues.
Yeah.
So they are very important for us to monitor. So here's a representation of those magnetic field lines that are all over the sun. And this instrument that you're seeing right here, so this is while it was being prepared before first light, will help us do this. So it's going to capture two-dimensional snapshots of the sun at specific wavelengths in the visible spectrum. That's the light that we're seeing, right? What it's doing really is it's measuring the polarization of light across that spectrum so it can analyze magnetic fields and how they affect light. So very, very important in being able to predict and have a better understanding of these solar flares. Again, this is to show you a comparison image of those regions. So here we've got a little, what we call a little prominence, so that little bit that's detached. We've got the Earth right there. And in fact, the etalons, so that is part of the instrument, we call them etalons, they are a little similar, this very large instrument, to what you might have if you're familiar with solar astronomy, astrophotography. It's a little similar to what we might have in a hydrogen alpha telescope, right? A little similar but different because it's working on, again, polarization of light. And here is the incredible image that was just released. And we've got a comparison to the size of the United States. This is the most detailed, highest resolution ever taken of image of the sun's surface. And it's a test run. And so each pixel in this image is about 6.2 miles on the sun's surface, or 10 kilometers.
That's crazy.
So
yeah. Now, everybody always uses the Earth for scale on all their sun images. And now they're using continental USA.
The U.S.
Okay.
country.
Okay.
It's pretty amazing. So you're seeing a sunspot here, by the way. So you're seeing one of those magnetic regions that we saw in that first image. So these regions can be about Earth-sized, or they can be a little bit smaller. A lot of them are quite small. So now we're finally going to have access to these tiny, tiny little sunspots.
Yeah.
Pretty exciting.
Yeah, the spot there's darker because it's cooler. The gas is cooled off a little. It's been held in place by the magnetic fields.
So important developments, and as we head into further solar cycles that could be very active. We had the slowest solar cycle, the previous solar cycle to our current one, in about 100 years. So we think we may be potentially, there's a new study that just came out, we may be ramping up to some more active solar cycles. So definitely
we might
important.
get a little double peak. It happens.
Might get
Keep
a
in
double
mind,
peak.
the sun
Yep.
causes the aurorae.
Yep.
Of course, during eclipses, you can see that corona, which is affected by the magnetic field. The surface of the sun. So their webpage has all sorts of information of the sun. Be sure to check it out.
Yep.
So, thank you, Lorme.
Yep.
So that's our first mostest. Stay tuned for future mostesses. So, Ginger, you've got some interesting images to show us.
Right, time for some pretty
Yeah,
pictures
absolutely.
here. So going to this one right up here. This is the featured picture of the month by the James Webb Telescope. And it combines infrared data from the Webb Telescope, showcasing these galaxy clusters, so incredible detail on these photos here. And then going to the next one, this is the X-ray data shown in the purple. So you can see that area of the hot gas. Pretty great, like getting to see them both side by side like that.
Webb, XXM Newton, and
Chandra.
Chandra data.
Yeah,
Yeah,
Chandra.
it's
That's why it's
all
important
of
to
them
be
combined.
outside of our atmosphere, right? Because we can access X-ray and other. Yep.
Exactly. So pretty pictures there.
Side by side. That's
side
just
by
cool.
side. Okay, so this next one, this is the most detailed image of a planetary nebula, NGC 1514, which is in, or 1514, which is in the Taurus constellation, approximately 1,500 light years away. And amateur astrophotographers, this is known as the crystal ball.
Never heard that.
It doesn't really look like that in this picture, but of course there's a lot more detail in this photo, and you can see that those two stars in the middle, you see the diffraction spikes, and they're actually on a 9-year orbit.
Wow.
So pretty impressive.
Okay.
That's why we're seeing
That's probably
those,
what caused that pattern, yeah.
the hourglass shape,
Wow.
exactly. Yeah, so pretty incredible. And then this one, as we were just talking about auroras, this is James Webb Telescope, the details on the auroras on Jupiter. And, you know, on Earth, they're the northern and southern lights, but here on Jupiter, you can see them in pretty incredible detail.
Wow.
This one I had to throw in because it looks like candy, you
That's
know,
great.
have to. So candy floss clouds, another one of the Hubble Space Telescope. This was also a picture of the week, and this is featuring the Large Magellanic Cloud. So that's in the southern hemisphere.
Yeah. Now the Hubble had an anniversary.
It did,
Yeah.
yes.
Right.
So this was part of their
Is it 35?
35, yes,
35,
that's
yeah.
correct.
Yep.
Yeah. All right, and as we are going, spring is a big, you know, galaxy season time. So I figured to throw in Markarian's chain, one of my favorites. This is located as part of the Virgo cluster. And I love this part here because it looks like a face. You have those two galaxies, M64 and 84. Is that right? Yes, 84 and 86, my bad.
And people can come see it here.
That's
Yeah.
right, yes. So if you look in our Gunther Depths of Space, that big picture down there, you'll see Markarian's chain.
That's right.
Pretty exciting. And then
Beautiful.
the last image, this is Rho Ophiuchi, a cloud complex taken with a Canon 5D Mark II and a Rokinon 135mm lens. Great amateur astrophotographer target for the summer.
Now, how did you know all those details about what this was taken with?
Oh, well, I took it myself.
Oh, gosh, Ginger.
And this
Beautiful
really,
image.
thank
Yeah.
you,
Wonderful.
thank you.
It's really cool.
It's
Yeah.
really one of my favorites. You have a lot going on here. So it's the closest forming star region to Earth, and it offers a glimpse of the birth of stars and planetary systems. So you'll even see that Antares, the orangish color star there, you'll see all that cloud, dust all around it. And then we also have a few clusters in there. I think like a globular cluster as well.
But where did you shoot it from?
Oh, so this
Not
was
Los
from a
Angeles.
dark sky, yes, not in LA.
Used to go
It'd
out
be really
there
hard to
on
get.
the sidewalk and point up in Silver Lake.
Exactly. No, this was like, I think, a couple hours of exposure on this one. So,
Okay.
but a great.
No, dark
Target.
sky, you're keeping your location a secret.
I'm keeping my secret. Yes, yes. I'm not giving those details away. So, but I also like to do it in July because it's, you know, it's like the 4th of July, all those colors.
Yeah.
Great
It's amazing.
fireworks in the sky.
Yeah.
And folks, if you are an astrophotographer out there, send your images in to us. Get in contact with us on our social media. Tell us you have an image, and we'll be happy to share what you've done.
Yep.
Well,
Definitely.
if it meets our standards.
That's right.
Ginger will be the judge.
I'll
of
try
this.
not to be too
Yes,
harsh,
exactly.
I promise.
Ginger runs it.
Yep. Well, thank you so much. Those are
Thank
some,
you.
some beautiful,
Beautiful
images this month.
Yeah,
So,
thank you.
Jared, yeah, thank you.
Thank you.
So, Jared, you've prepared and out to launch for us. More stuff is happening out there in space.
Yeah, if you can believe it.
I know.
So it's like there's so much stuff that's been going on. One that we did not get to cover last month that I think is a pretty big deal, and seemed that a lot of people actually ended up missing this. So I think I would highlight it was the Fram 2 mission. So Fram was originally a Norwegian expedition in the golden age of polar exploration. It was a ship, one of the first that went to both the South Pole and the North Pole for both exploring both of those. And this mission actually launched on April 1st, and this was the first crewed polar launch ever. So we actually never launched a mission with people on board into a polar orbit. And a polar orbit is exactly what it sounds like. It's an orbit that has such a high inclination that the vehicle is going over the North and the South Pole. And the inclination that they chose for this was 90.01, so very precise. You get to 0.01, so it becomes a retrograde because it's on the opposite direction that the Earth rotates. But sure, we'll give the 0.1 to them. And it was studying auroral phenomena as well as reactions of human physiology to spaceflight, and they're also growing mushrooms, or at least attempting to grow mushrooms for the first time in space. No reports yet on that. But just to let you see some of the views that they got here, let's go back real quick as we take a look at those views. They're pretty nice views, as you can see. So
It looks like space.
yeah, it definitely does. Let's try one more time to take a look at our friends here with their views.
What we've done there.
But they were absolutely, I can assure you, they were absolutely beautiful. So if you head online, you could take a look at that and get some good views of the Earth from orbit. Now, also, in addition to some other things that have happened this month that are interesting and just don't seem to be talked about, which is that Amazon has launched their first rocket delivery service. Actually, I'm just kidding. It was the first launch of the Kuiper satellite constellation. So this is going to sort of be the competitor that Amazon is running to compete with SpaceX's Starlink system. So here we go. Another satellite constellation that astronomers on the ground get to contend with. But this one launching 27 at a time. And they have a total contract with different launch service providers. The contract has 92 launches. So they're going to be launching somewhere on the order of about 3,000 satellites to make up this constellation. So quite a lot. And I just thought it was hilarious seeing this big Atlas V rocket right here with the Amazon logo on the side of it. So as far as I'm concerned, that can deliver a package at my house anytime that it would like to. And then we had, unfortunately, a failure, because sometimes we do talk about the failures. Oh, we do have some video
Oh yeah, this is
here. So we could, if you'd like to watch this.
Oh yeah, we should see this.
Yeah, we could take a look at this. This is specifically a Atlas V in the what's called the 551 configuration. So the first 5 meaning that the payload fairing is 5 meters in size. The second 5 in there means that it has 5 solid rocket motors on the side right there, and then the 1 means that the upper stage, which is called a Centaur, only has 1 engine. And putting 5 solid rocket motors on an Atlas V, that's the hot rod of the Atlas V collection. That's the Mustang with the 5.0 V8 in it, as it were. So it gets cooking up there pretty quickly. And it was a really weird launch too, because after stage separation, they turned off the cameras, and then they're like, "We'll update you a little bit later on it." So that's kind of bizarre with that. But we did end up getting footage of the Kuiper satellites being deployed here. So this is the first time we actually ever got to see the Kuiper satellites, because they have been very top secret for whatever reason.
How bright are these going to look in the sky?
That's a great question. I'm not sure. But you know, them and SpaceX, to their credit, at least did come to astronomers to try to say, hey, what can we do to mitigate this?
It was all nonsense, Jared.
Didn't work. Didn't work.
It was all, well, but their mitigation
So.
was for people that are doing, frankly, amateur astrophotography, doing things that aren't looking at really, really faint things. When they said, oh, we're going to dim them down to 6 magnitude so you won't be able to see it with your naked eye, I was like, okay, nice, but that's only 1,000,000 times brighter than the stars I studied in my thesis.
Yeah.
So professional astronomers doing research with our most expensive telescopes and the Hubble Space Telescope, and okay, the Webb luckily is beyond where these things can affect them, but it's a problem. They're showing up in Hubble images now.
Yeah.
So
Yeah,
anyway, but I'm kind of resigned to it now because Amazon's launching, the
No,
Chinese are going to
we
launch.
shouldn't be resigned.
Well, it's,
I was going to say,
hard.
we went camping first time for a very long time about a month ago, and I've never seen that many satellites before.
Yeah, it's
So last time I was out camping was before we started launching these mega constellations. So take that as you will with your views. But Firefly Aerospace did launch their Alpha vehicle for their very well-titled mission, Message in a Booster. As a fan of the police, I was very much enjoyed that there. But there was just a slight issue. So first of all, it's Vandenberg here in California, so it's foggy, so you get to see it for a couple seconds here. And then we skip ahead to stage separation here. I was watching this live, and when I saw this bit happen right here, I thought, oh great, there went the vehicle, that was it. And then great, now we have a close-up of a vehicle that's just blown itself apart. Like, that's a great thing for your PR department to have to fix. And then we got this view, which is from the upper stage looking down where an engine should be at. And we can see it's still firing. And the guidance, navigation, and controller, the GNC, is fighting with all it's got in order to keep it stable like it's supposed to. And I could not believe what I was watching with a whole bunch of people here, which is that we're watching the combustion chamber of the rocket engine just keep burning without the nozzle. Who cares about the nozzle at this point, I guess? So just to slow it down and take a little bit of a look here, there is no official word yet from Firefly Aerospace as to what happened. The speculation is that during staging, the first stage may have actually recontacted the second stage and broke the nozzle.
Yeah.
And obviously with a broken nozzle, it was not efficient enough to actually get it into orbit. So it did crash into the Pacific Ocean just before Antarctica, where an area is set for things like that to happen, just in case. But here you go. So on the left is a earlier mission called Fly the Lightning. And you can see there's a nice nozzle, as it's supposed to be, and then message in a booster on the right side there with no nozzle, which is not how it's supposed to be.
That's not how it's supposed to go.
Don't they have to report to the aviation authorities?
Yeah,
FAA?
so FAA, so they are grounded. The FAA does have to do an they have to do an investigation and then present the results to the FAA.
And I guess then we'll know what happened.
Yeah, and actually what's very interesting about Firefly Alpha is that with their previous anomalies they have had on their Alpha rocket, they've actually been extremely transparent and open about it, unlike a multitude of other aerospace companies that we just end up finding out through back channels or never finding out as to what happened during spacecraft anomalies, or rocket anomalies. So yeah, but obviously hoping that they can figure it out very quickly and then
when was
continue
this
flying. This was launched on April 29th.
Oh, yeah. So a few days ago.
Yeah. So not long ago.
Well, thank you for that, Jared.
Thank you.
As always, an interesting out to lunch. So thank you, Ginger. Thank you, Jared. Right now, we're going to swap Ginger and Jared out for our special guest night. Thank you. Yeah. Applause for our... So tonight, we are celebrating 90 years of public astronomy. So I'd like to welcome Observatory Deputy Director Mark Pine and Foundation Executive Director Elizabeth Greenway to the show. Welcome. Thank you. Nice. So we've been celebrating our 90th anniversary all year long here at All Space Considered, so you can go back and check our various shows, and we've had various segments and things. Our last show was very fun. I recommend people go take a look at that. We pretended we were back in 35.
Before we opened.
Yeah, right before we opened. So the astronomy was crazy, floating ammonia islands, things like that. But a lot happened in the last 90 years. There's been all sorts of public events, all sorts of things like that. And Mark, what do you think has been the most impactful thing that Griffith Observatory has done?
I think I have two answers to that. And they both actually are not momentary. They're both sort of continuous. From the observatory is free. And because the observatory is free, people come to it and they do what they want. We have 7 entrances. There are no ticket collectors. As a consequence, some people come in, they go to the bathroom, they go back out. They don't even think about it. They're hiking. Some people come in and they read every caption in the building and they see every show. And they spend 5 hours here or 6 hours. And then everything in between. And at no point are we telling people this is the experience you have to have. We're inviting them to have the experience that they want to have. And hopefully somewhere along the way to be inspired by that experience. And then the second thing is, in addition to that, we meet people where they are. Because we're free, because people can come here anytime they want, our audience is a general public audience. That means there are people who are deathly afraid of math and science, and then there are PhD astronomers. And everything like before, everything in between. And so we have exhibits that are written at a certain level that are trying to be welcoming and inspiring and visually arresting so that people will have that experience and that we'll meet them wherever they are. And we have guides like Laura May and Ginger and Jared who will help people who want to know more and who can be inspired by the questions that they ask and the answers that they get. And then we have shows in the Samuel Ocean Planetarium, in this theater, the Leonard Nimoy Event Horizon, that will help those people to have whatever the depth of the experiences that they want. And maybe when they walk out, they will feel better about the idea that, wow, astronomy is for everyone. I can be part of science. So, you know, there have been, like you said, there have been a lot of events along the way,
Well, yeah.
but the through line has been that experience for people. And then I guess the final thing I'd say is the observatory is for people, but it's also presented by people. And so we have guides, we have telescope demonstrators who show people how to use telescopes. All of our shows in the Samuel Ocean Planetarium are live shows. They're run by somebody and they're narrated by somebody, not a recording. We have people who sell you tickets. We have people who usher in the theaters. Every moment that someone spends here is produced by a person. And we're really grateful for our staff, and we've had wonderful staff for 90 years.
Yeah, well, speaking of,
Here.
with all these events we've done, huge things. Comet Shoemaker leaving 9, smashed into Jupiter, leaving these Mars. People flocked up here. Halley's Comet. By the way, we're running lots of slides in the background for folks to look at of just events we've had, and you'll see some of these. You'll see the Halley one. You'll see the. But how does the observatory prepare for this? We have all this staff, but how do you coordinate it all? How do you make it all work?
That's actually a very funny question. Because you would think, oh, well, there's an absolute template that you can use for everything, but that's absolutely not true. Because sometimes things happen that you can't fully prepare for, and you've seen a picture of it, and that was the space shuttle flyover. The space shuttle flyover was one of the first massive events that we ever undertook, except that we really didn't know that it was going to be a massive event because it really wasn't an event of our making. It was something that was going to happen in the sky nearby, though not entirely clear how close. And it was supposed to happen on a Thursday. Yeah. And so we figured on a Thursday, people will be working, their children will be in school, they will all be serious people who will do their thing, and they'll stand on top of the building that they're in, and they'll look up at the sky, and they'll see the shuttle come by. But then at the last minute, it got moved to Friday. Now you might say to yourself, well, Friday is also a weekday where people are working and going to school and all of those things. But no, in fact, Friday is apparently a day where everyone feels like they can abandon all of those things and come to Griffith Observatory. And we're enormously grateful that they did, but we did not fully prepare for that.
No.
And so the roads were crowded, and fun fact, if you get 3 calls to emergency services about the same thing from the same place, you become an incident. When you become an incident, a whole bunch of fire trucks show up and a canopy with a fountain and all of these other things. And so the traffic jam that we had before that was accentuated. It is the only day in my 28 years here at the observatory that I have felt that there were too many people on the hilltop. But as a former NASA person, I will tell you, it was one of the most inspiring things I've ever seen, and I wouldn't trade it for the world. But we learned something from it, and so then 6 months, now forward 7 months into the future, and it's December 21st, 2012. It's the day that allegedly, and not really, that the Maya predicted that the world would end. And we did a new planetarium show about it for the Salmon Ocean Planetarium. And in advance of that happening, believing that we could be overrun by people, and in some cases people who might have very distinctive views about the end of the world, we met with the fire department, the police department, the park rangers, the park itself, every emergency services and everything else, and we had over and over and over planning meetings. And we get to that night expecting crowds of thousands, and we're ready, just totally ready, lots of staff, and it's cold. And if there's something in Los Angeles that will destroy your event, it is cold.
And the rain.
And by
So much.
cold, what I will say to you is, it was 51.
Ooh.
I am from Ohio, and so I know what cold is. 51 is not that. But nonetheless, in Los Angeles, it was more than sufficient to drive down our numbers. About 400 very game, very enthusiastic people showed up, and we had a gong, and at 11:59, we banged the gong, and Dr. Krupp allowed the clock to tick over, and then it was 12:01, and the world was still here, and everyone left. Which is exactly what they should do. And so, what you do is you have events, you learn something from them, you hope to plan for better in the future.
It's different every time.
It is a little different every time, although as time passes, those lessons build, and you become better and better and better prepared for what's going to happen.
Yeah, one event that I know we weren't quite prepared for it, but we pivoted very quickly, was the opening of Light of the Valkyries. And we had people show up in Viking costumes.
Yes, that is true.
With
Excellent.
swords
The sword.
and axes.
The
We had
sword.
to quickly
I know
get a
it's
weapons check put together.
Yeah.
Because weapons aren't allowed here at Griffith Observatory, folks. Leave those at
Mjolnir
home.
at home.
Or
Oh,
anywhere
that's
in the
Anywhere
City
in
of
the
Los
park.
Angeles Recreation and Park system.
Yeah,
So please
not-
don't take your
no.
sword to any of our
Well,
parks.
if you're fencing in an organization, maybe, but these were
Possibly.
Vikings.
Yeah, no, they were.
LARPing up
Yeah,
here.
these were big
Yeah.
swords.
Come and LARP.
They do LARP.
Yes.
Well, yeah, anyhow, but we do learn things. Well, Elizabeth, you are new here at Griffith Observatory, so some of this craziness we do here.
Oh, I'm all in.
Please still
Yeah,
stay.
please stay.
Yeah, okay.
Please stay.
Hey,
Be
You
friends.
were formerly,
people.
formerly with one
found
of my
you. So
favorite
happy.
organizations, the Los Angeles Master Chorale, who are just lovely and so wonderful. But which of our programs are you most excited to help us support?
Oh my goodness. Well, I have to say, I love what you said, Mark, about the fact that the observatory is free for everyone, and it always has been. And I think what's more cool about that, for me, that this observatory belongs to everybody. It belongs to the citizens of Los Angeles. You make this place available to each other and to anybody who comes here from anywhere around the world, across the galaxy. And that's so special. It's your observatory, and we get to share it with each other and make it shine for everybody. So I think that's really powerful. It's so rare. And I come from classical music. Before that, I worked in independent film, and then before that in contemporary art. And one of the coolest things that I'm learning about what observatory teaches us is a lot like what you learn when you're looking at art. It teaches you to slow down and just look, take note. Take the time to observe what's happening around you objectively with a little bit of patience. And if you can give yourself that gift, you get such rewards, and you get to discover that. It's like looking at a painting. You start to say, okay, well, it's blue here, and there's people over here, and they're wearing this hat, and why is that reflection? And what's that line? And
look
why
at
does
dog.
it move in this way? And wait a minute. And then once you start to really give yourself that gift, you start to really discover something, and that's so powerful. It helps you understand how you can maybe get along in the world a bit. Take time, observe, and maybe try to make some meaning. And then you find a community around you that's making meaning out of it, and then all that, brings us something really powerful. So I'm loving that.
If you stand on the lawn of the observatory for 15 minutes, what you will see is it's people from every part of Los Angeles, which is one of the most diverse cities in the United States. And you will see people from all over the world, and you will hear dozen languages or more. And people come, as I said, and go as they please. And it all feels very comfortable, and people do take ownership of it, and they do enjoy being here. If you work here, just like any workplace, David and Laura May can attest to this, there are days that are challenging, like when we're planning events.
Or Mark Twain days.
Or yes. But then you walk outside at the end of the day, and you're in a park, and you're walking down the sidewalk, and people are on the lawn, and they're just having a fun time, and the sun is setting, and it's so beautiful, and those cares just kind of melt away.
People are getting engaged all the time.
Yeah.
Yes, they are.
It's amazing.
This is one of the top date locations in Los Angeles.
Yeah.
So many engagements.
Yes.
So I've been, this is my 25th day on the job, so I'm in. So what's been so cool, like I get here every morning, and the observatory doesn't open for 4 hours, and there are people out enjoying the view. Their school buses arriving, and so the thing that's really been like my favorite part of this job, and the thing that I'm so proud of as the ED of the foundation, because this is our raison d'etre in so many ways, are the school programs that we have. We're serving like 27,000 kids in 5th grade come up here, and so I go down every day and I start to talk to them, and I'm chatting with people, and by and large the people that I'm meeting, like a lot of you guys, first time at the observatory was in 5th grade when I came with my class, and it changed me, and I love it, and I feel like I know this place because I had that experience, and it was so magical. So you got that, and then all of the tremendous work that the guides are doing to lead the tours. I mean, I tagged along with one the other day, and we were down in the looking at the Gunther depths of space and blowing little minds, and then out comes a meteorite, and everybody's like, from the Big Bang, it's fantastic, and
this
so
meteorite's older than your teacher, kid.
So, that's super.
And
cool.
several of those guides
Wow.
also were actually on the school program when they were younger.
Yes.
Some of the native Angelinos, Jared, that's really cool.
Speaking to the people, that community is just so inspiring. I'm having the best time.
And you also attended the online school program, right?
So good. So I jumped into module 4. So like you were saying, Mark, the online school program is a live program. It's delivered live by museum guides into classrooms all over the place. And what's been really cool is seeing how each one of the guides presents the program, and then there's a whole Q&A at the end. So I'm watching, and like 360 questions are coming in at the end of a module on exoplanets. Okay, Mars, lots of Mars.
Lots of Mars. Yeah, a lot of them get
Lots of
personalized
Mars.
answers typed back to them, and then a lot are verbally answered.
Yeah.
So it's amazing what the crew is able
We
to
try
pull
to
off.
answer usually around between 50 to 100 of them.
Yeah.
And the classic question that we always get that I have to ask you, oftentimes we get asked, what's your favorite plant? And I'm presuming that they're not that interested necessarily in...
It's an orchid.
That's right. I think they're interested in planets. So do you have a favorite planet? Or?
Of course. Well, toujours pour moi, la vie en rose. So the rose is my favorite plant. So we'll get that out of the way. Favorite planet, no doubt, Saturn.
Oh,
so
yeah.
good.
Saturn's gorgeous.
I mean, raise your hand.
Yeah.
Saturn's so good.
And part of the
It's the
reason that
best.
we exist, that, Griffith J. Griffith looked at Saturn through a telescope.
Yep.
And wanted everyone to have access to this, which is one of our raison d'etre as well. So, a great choice.
Now our foundation has been instrumental in so many of our projects. The renovation we wouldn't have been able to do without Griffith Observatory Foundation. It was known as Friends of the Observatory at the time, but same organization, the heritage is there. What is happening now that you can talk about that folks might want to hear about that the foundation's helping us do?
So many good things. So the foundation was established in the 70s to build a program of members and donors to help sustain the building and ensure that it was going to be really thriving into the future. So that's how it all started. And what the foundation has been doing really recently is investing in all kinds of great infrastructure, but also all kinds of tech. So for example, we're sitting here in the Leonard Nimoy Event Horizon Theater. which I love to say. I'm never going to get sick of it. It makes me so happy. So we help, fund a really great upgrade here in the theater. So you're hearing us in Dolby Atmos.
That's right.
The audience is listening.
It's so good. It sounds amazing in here, and that's like state-of-the-art stuff. And the projector system
Brand new
went
projector,
from
so much
HD to
nicer.
4K. So that's cool, and that was all funded by members and donors through the Observatory
And
Foundation.
that was just stage 1. There's a stage 2 and 3 that are still coming to our theater. So come visit us, and you can see it evolve over time.
Get ready. We help to fund the Wi-Fi up here on the hill, so enjoy.
Important.
Exactly.
Super
the
important.
public can now get pretty darn good Wi-Fi in a lot of locations up here.
And can leave as well.
That's
which is
right.
important sometimes.
Trying to get an Uber used to be
Coming here.
impossible.
Oh, that's how I'm
It was a
getting home
problem.
today. I mean, it's so reliable.
It's really, really great.
And the other thing I wanted to share, I was just coming up the other day and I saw a guy had a real thick Australian accent. What's up, Australia? I hope you guys are watching us right now. I don't know what time it is there, but cool. And he's on FaceTime with his family at 8:30 in the morning, talking to his folks, and everybody. He's showing them the Hollywood sign and the observatory. Those are some of the things that the foundation's involved in right now.
As Dr. Reitzel said earlier, the observatory is owned and operated by the city of Los Angeles and the Department of Recreation and Parks, of which we're a part, and very proud to be a part, inside Griffith Park. And the city is responsible for the operation on a day-to-day basis. So Dr. Reitzel and Laura May and myself and Jared and Ginger and pretty much everyone else you see who's on our staff is a City of Los Angeles employee. And so you might say to yourself, well, if we have all of that support and it is the support that keeps us going every day, why do we need people to join and donate to the foundation? And the answer is all of the things Elizabeth just said. So we can have even better, even more programs, more capabilities. Our ability to do online broadcasting like this, online broadcasting of astronomical events, David was one of the pioneers of that. That's because of a donation, many donations from the foundation. So I encourage you, as someone who used to sit on the board of the foundation and was the foundation's first full-time employee, I encourage you to join the foundation and to support the foundation, because in doing so, you are supporting the observatory and its programs and its ability to serve you. And I will say that one of the reasons why I joined the foundation initially was because the foundation has the most simple mission statement of any organization I've ever encountered. Their mission statement is Griffith Observatory Foundation supports Griffith Observatory. That's it. Nothing could be more transparent than that.
cool.
I can tell you, having been on both sides of that partnership, that is exactly what Griffith Observatory Foundation does. So I commend it to you. I am a donor. I am a member. I
That's
hope
how-
you will be too.
Please do. That's how we got involved.
Exactly.
We joined as members, and this is a few years ago, and we got to know, and we come up here for years, and we love the place, and we bring our friends from out of town and family when they visit, come to events and things like that. But we have had so much fun as members coming to see screenings and events, and the community here is so great. So yeah, come and join us and
And
be with your
volunteer.
people.
People can volunteer.
So
work
good.
our events. and-
Nice people.
A couple of things. You can join and you can come up for special events, and maybe you'll get to buy a ticket for rooftop celebrations during things like
That's it.
eclipses or shuttle flybys, things like that. Or just donate. There's a donate button right on the YouTube page there. You can click on that. Give us $1 million. We won't complain. You don't need to come to any of the events if you don't really want to. But I recommend you do, because it's a lot of fun.
100,000 would be fun.
100,000 is fun.
Every dollar matters. We have
Every dollar matters. Even a
millions of
$5
people.
donation,
That's right. Coming here every
$2.
day.
Yep.
Do
It's
it.
all
we need
adding
it, and
up.
we
Yep.
appreciate it so
really,
much.
really, really
Yep.
appreciate
Here,
it.
here.
And we're all, like everyone else in Los Angeles, we are slowly but surely, steadily, little by little, as Elizabeth was saying, we're trying to shine up the place for 2028.
That's right.
We want the observatory to shine just as brightly as everything else in Los Angeles is going to when the world comes and turns its eye to Los Angeles, which seemingly is every day, but I think during the Olympics will be even more. And so we've got a lot of things planned over the next 3 years to keep the place growing and getting better and better and better to serve everybody.
I need us to do better than Paris. I'm from Paris, so we
That
now
is a
need
high-
to make
I will say that was a fabulous high bar.
Although, don't we have a World Cup coming before?
We do.
the
right.
Olympics?
Next
So
year.
then, yeah.
Next year.
There's just Los
LA
Angeles
is
will
the
be
place.
focus,
It's gonna be the
and
center
people
of the
come to
world.
Griffith Observatory when they come to Los
Yep.
Angeles for these events. We have it's like 1.5 million visitors a year, roughly, that are visiting right now.
And it's no coincidence that if any of you saw the opening video, the introductory video of the Olympics that was done at the end of the Paris Games, when Tom Cruise was doing whatever he was doing to the Hollywood sign that was disturbing. When they were done with that, then the camera turned around, and there was Griffith Observatory with downtown Los Angeles in the background. And so if you want to know that you're in Los Angeles, then you see a picture of Griffith Observatory, and that's when you say, oh, that's Los Angeles. That sounds good. I want to go there.
Will the traffic be worse then?
It will not.
It'll be
It was, I'm telling you, people in 1984 say that the roads have never been clearer prior to the pandemic. Everyone who would normally visit, everyone either from out of town or in town will just simply step away for those 17 days, and all of the people coming to the Olympics will just step in.
That's right.
I actually expect our attendance will be just about the same. It'll just be completely different people.
Paris was like this, so a lot of my friends and family left, and people came back.
So now, if people want to get involved with the foundation, what's the easiest way to do that?
So easy. You can go to our website, obs.org, and then you've got all kinds of options. But there's basically 3 things you need to know. You can donate $1, $1 million, anything in between. You can become a member, and like I said, so much fun in the membership program. It starts at $65. You know, that's like $5 a month, and you're having a blast with all kinds of great people. Reading the Griffith Observer comes in to play, and if you have not received this newsletter, you must get it immediately, because we read it at our kitchen table every month, and it's brilliant and hilarious. And then from then on, you know, all kinds of great member benefits, you know, reserved parking and tickets to the planetarium shows. So this is a really great way to get involved. And then third, you can volunteer. And the core of volunteers here, they're amazing. You guys are amazing. You make it all so fun, and you make us all feel so welcome. So this place is for you. It's yours. It's ours, and the foundation is here to help it shine. So
Awesome.
Please do get involved.
So, any questions in our audience here? I know we're running a little long, but if anybody's dying to ask something, I think we've covered most everything. So why don't we thank our guests again? Thank you so much.
Thank you. Thank you.
Guys,
Wonderful.
thanks for having us.
Yeah. And to finish tonight's program, once again, All Space Considered is brought to you by the City of Los Angeles Department of Recreation and Parks, and we thank Griffith Observatory Foundation, our exclusive nonprofit partner. And now I'm going to show you a little video. I spent some time yesterday on our 90th interviewing folks out on the front lawn and out on our plazas there about what's going to happen the next 90 years. So I hope you enjoy this little video to close out the show, and come join us next month for All Space Considered as well. Hi folks, it's Griffith Observatory's 90th anniversary today. Welcome. Yeah, we're making a little video for our YouTube show we do tomorrow night. Do you want to be in it? We're just asking people what you think will happen in the next 90 years. What do you think is going to happen in space and astronomy in the next 90 years?
We can say we'll landed on Mars.
Landed on Mars. Maybe so.
Maybe make a city over there.
A planet just like Earth that we can go to and visit and colonize.
I have no idea. I'm trying to figure that out.
That's why you're at Griffith Observatory?
Yes, that's why I booked the show. I was like, what's going on up there?
Maybe Mars, maybe more.
I think we're eventually gonna learn more about Mars, because people will be going to Mars and stuff, and going to other planets, maybe discovering planets that we don't know about.
What's beyond the solar system? Hopefully we learn that Pluto is a planet again.
How stars travel, how comets are traveling, and how they interact with planets. I guess just more about that, and thinking about more about the origins as well of life.
Well, integration with AI and all of the crazy stuff that's happening. Like, if you watch the Black Mirror, just referencing that show out, it's a really good show, by the way. No sponsorship.
Yeah, what do you think we're going to find?
Aliens.
I mean, it's a big place. Surely we're not the only ones, so we'll find something.
AI.
AI. Well, what do you think of anything amazing it'll do with space?
Maybe a instrument, a kind of something that could help us to, be kind to the other people.
At the rate of exoplanet discovery within the past, since the Hubble telescope came out, that, I guess quite frankly, the next step would be getting satellites out there and truly studying them to see what is the most Earth-like planet that we could find.
I think it would be really cool if in the next 90 years we found a way to go inside of a black hole.
It would be awesome to find the grand unification theory.
Technology is kind of advancing a lot, really quickly. I think we'll be able to, learn more about how the universe works and how planets work. Yeah.
I'm hoping that we discover what dark matter and dark energy actually are. Some of those things that are mysterious to us.
What do you hope we discover in the next 90?
Oh my God, that's such a hard question. I'm not prepared for this. Don't tape this yet. Hold on, I gotta think about it.
Thank you.